All right, well, it is 5:30, so let's go ahead and get started. Hello, everybody. Thank you for making it today to the COVID-19 speaker series. I understand that these are challenging times for many reasons, but we're so happy to have you guys tonight and hope that this is a fun and educational webinar for everybody here. We are here to build RAM community and be a resource, and hopefully this webinar is one way that we can do that for you. Again, just wanted to thank everybody for being here. If you guys don't mind, while I'm talking, you guys can take a moment to put in the chat your name, year you graduated, where you're from, and make sure that you change your "to" right now in the chat that says all panelists to all panelists and attendees. That way everybody else can see. And again, if you guys are just now tuning in, I know that we just hit 5:31. We're putting in our names to the chat right now, year that you graduated and where you're from as well. We have a lot of alumni members that are attending tonight, and we thank you especially because without your membership for the Alumni Association, we would not be able to be hosting events like this right now. We would not be able to be hosting events in person once we get back in person, so thank you so much for your membership. I would also love to throw out that we do have a couple of lifetime members here today too. So thank you guys for everything that you're doing for the Alumni Association. I would also love to thank all of our partners with the COVID-19 speaker series. We have Women in Philanthropy. We also have the Office of the Vice President for Research, as well as the College of Veterinary Medicine and Biomedical Sciences. Without them, without those departments, we would not be able to be working with our presenters for tonight, as well as any other presenters that we've been having on our other presentations too. In just a moment, I'm gonna put a couple things in the chat. One, if you get disconnected or having an issue, it'll have a little link that you can click on that'll show you what you can do to troubleshoot. I'll also put in my cell phone confirmation as well as my email confirmation. And then we'll put in a couple of links from the Office of the Vice President of Research, College of Veterinary Medicine and Biomechanical Sciences, as well as Women in Philanthropy, and some information about the Alumni Association as well. So if you have any questions, feel free to click on those. I'll do it once I'm done talking, and then I will do it once before the event is over. I do want to make everybody known that we are recording tonight, but we cannot see you guys on your screens because it is a webinar, and we cannot hear you as well. The only people that you can see and hear are our presenters. If you have a question, please feel free to put it in the chat or put it into the Q&A box at the bottom of your screen. We will be monitoring them and then answering all the questions at the end of the presentation. Without further ado, I would love to announce our wonderful guest speakers for tonight. We have Dr. Karen Dobis and Dr. Brian Wilson. Dr. Dobis is the director of the research, I'm going to say this right, the director of the Research Integrity and Compliance Review Office. And Dr. Wilson is the executive director of the Energy Institute, holder of Brian Wilson Presidential Chair for Energy Innovation and a professor of mechanical engineering. Without further ado, Karen, go ahead and take it away.
Thank you, Corey. Thank you for everyone for being here this evening. I am going to be talking about PPE and disinfectants, and affectionately subtitling this in the spirit of the holidays, pains, trainings, and automobiles, supporting the CSU community during the emergence of a global pandemic. Before I begin, I just want to take a moment to read that Colorado State University acknowledges with respect that the land that we are on today is the traditional and ancestral homelands of the Arapaho, Cheyenne, and Ute nations and peoples. This is also a site of trade, gathering, and healing for numerous other native tribes. We recognize the indigenous peoples as original stewards of this land and all the relatives within it. As these words of acknowledgement are spoken and heard, the ties nations have to their traditional homelands are renewed and affirmed. CSU is founded as a land-grant institution and we accept that our mission must encompass access to education and inclusion, and significantly, that our founding came at a dire cost to Native nations and peoples whose land this university was built upon. This acknowledgement is the education and inclusion we must practice in recognizing our institutional history, responsibility, and commitment. And for those of you who don't know, this tree is called Council Tree. It was a gathering tree um, by many of the Native peoples, and it's still on the southeast corner of Fort Collins. So, as I'm sure you're all aware, at the emergence of the pandemic, there were immediate shortages and price gouging and hand sanitizer, disinfectants, things that we all experienced, as well as things that we heard about with regards to personal protective equipment. And PPE normally means gowns, surgical masks, and then the N95 front face respirators. At the same time, there was a dire need to conduct surveillance on at risk groups, especially in skilled nursing care facilities where you have persons that are at higher risk of severe illness and risk of spreading it to other impacted persons. And on the back end, then there's a need to support the research staff and the people that work in these environments with trained transport of specimens and also all these above items. There was a need to support CSU essential workforce and the CSU investigators that I'm sure you've all heard about that are conducting research and surveillance activities on COVID with PPE, disinfectants, and hand sanitizer to keep them safe. And then there was a need to support CSU satellite and sister facilities, especially our agricultural partners who were beginning their planting season or pruning season as they get ready for the spring and summer months. And they also were in need of hand sanitizer, disinfectants, and at least some personal protective equipment. So I always have to say this, tuberculosis is my jam. So CSU is home to one of the largest tuberculosis research teams in the world. And why I introduce that is because it is a highly trained professional workforce with passionate student staff and a lot of resources and infrastructure to support a pandemic, especially when we are talking about aerosolizable infectious diseases. So we readily grouped and thought about what we could do to support the immediate needs, and that included making hand sanitizer, something very simple for us to make. We had access to the WHO preparation for hand sanitizer, and um, and obviously the infrastructure to do it. And so this blue canister that I'm showing is a 55-gallon drum of 100% ethanol that we had delivered to the lab, and the little weird metal thing that was on my title slide was actually a key that you use to open that drum that we didn't have access to. So it was actually kind of funny driving across campus and grabbing that and coming back and opening it so we could start working. I always do like to have a little bit of extra education. So my sidebar is that 70% ethanol is what a lot of people have been told. This is a great disinfectant. This is a great disinfectant, but it's not always a good disinfectant for all infectious diseases. And so I have this beautiful picture of beautiful Mycobacterium tuberculosis, which, as you can see, is this thick crust sitting on top of liquid media. And for an organism like that, 70% ethanol is not going to be effective at all. However, very effective for mitigating and inactivating SARS-CoV-2 and other similar viruses. So something that could be readily available. We instantly had growing pains, however. Hand sanitizer and disinfecting wipes as well, which was basically we were cutting up cloths and then making disinfecting wipe solutions in mason jars. And then we were getting the dirty wipes back, cleaning them, and then making new wipes and sending them back out. That was conceived and discussed with the Office for Vice President of Research on March 12th. I was walking across campus from just finishing teaching a class. We had that drum delivered and started production beginning of the next week, which was spring break, and we began to fill our capacity by the end of that week. So on Sunday evening, I got a hold of Charlie Hoxmeyer from the Gilded Goat and asked him for his assistance. Um, The challenge with disinfecting wipes was that there was a lot of mixed information and disinformation about what would be appropriate for for disinfecting and stopping the spread, the contact-based spread of SARS-CoV-2. And at the same time, we didn't even know how stable this was and whether there really was a need to be wiping everything down. Was it aerosol borne? Was it contact borne? And so I think that caused a lot of concern around the community. So I'm now going to challenge my technical abilities by going to the next little video clip. I'm sure some of you have already seen this, but it basically illustrates where we moved this project from just being within CSU to working with our partners in Fort Collins. Try this. Can I just have someone in the chat or even Corey let me know if you see the video now to confirm?
I can see the video.
Excellent.
So it's been kind of a scramble mode to figure out how we get by now under this pandemic. I got a phone call from my former graduate advisor, Karen Dobos, that CSU was running dangerously low on sanitizer and asked if I would be able to help.
So a few of us here at the Mycobacteria Research Lab are making hand sanitizer and homemade disinfectant wipes because there's a shortage right now, and we're trying to provide those to other labs around campus that are doing essential work that can't stop during the outbreak.
I know a lot when this outbreak happened, a lot of us knew that we're scientists, that we could help in some way. We just didn't really know how, and we felt a little stuck. So having the opportunity to provide anything to the community to help really makes us feel a lot better.
So a barrier to our ability to produce a lot of hand sanitizer is our ability to acquire ethanol, which is a primary ingredient. And as you can imagine, breweries have a lot of ethanol available and can produce it in mass. So Charlie, who runs the Gilded Goat, used to work in our lab before he started the brewery.
So we reached out to Jason Hevelone at Copper Muse Distillery, who produces ethanol as part of his distillation process. So he's providing the ethanol for the hand sanitizer. CSU is providing some of the other ingredients that we need, and then Gilded Goat is formulating the batch and doing quality control to make sure it's up to WHO and FDA standards, and then delivering to CSU as much and as often as we can.
So we're providing it to the vet teaching hospital, medical centers, and housing and dining services.
It's nice to be able to stay involved with the university that's given us so much, and be able to be in a position now to help them out.
So no matter, I really enjoy being able to talk about that partnership because it's just been so beneficial, and that continues to this day with the Gilded Goat also partnering with Old Elk Distillery in order to make sure that we have a continued supply of hand sanitizer, not only to the CSU community, but also our sister and satellite communities, including Colorado State University Pueblo, the U.S. Forest Service, and our agricultural research stations on the western slope and in south central Colorado. So that brings us to the next hurdle, the automobiles. Delivery was our next big challenge. We had students, staff, families serving as couriers. My daughter came to visit me. She's a Fort Lewis college student, and she visited me for Mother's Day. And on her way back, I loaded up the Durango. I loaded up her Subaru with a bunch of hand sanitizer and told her where she was going to be dropping that off on her way to various satellite facilities, and including a Forest Service site at Fort Lewis College. So we did get assistance from emergency management, especially Ken Quintana, who's just been a superstar, and Tom Hickey. But again, they even started exceeding their ability. So we had a huge lift from central receiving, specifically Steve Byrne. And basically we went to having the hand sanitizer delivered to central receiving, and then central receiving could then deliver it to everyone as part of their mail service. Steve Byrne and his colleagues also built a PPE storefront so people could just do one-stop shopping, order what they needed, and then have it delivered through central receiving. And he also helped design sort of an innovative hand sanitizer disinfectant station. And if you want to know more about that, there's a wonderful story on the source. So you've heard about the pains in the automobiles, but the trainings were significant. For example, hand sanitizer does have a very high content of alcohol, and the transport of alcohol is enforced by the ATF, obviously, for ingestion purposes, and then also by the U.S. Department of Transportation because it's very flammable. And so we had to get exemptions for transporting this in our personal vehicles in high quantities. The guidelines for collecting or handling transport of biological specimens was constantly changing with the CDC website. We had to also protect ourselves, so there was multiple different reading up on needs for the OC Health and Safety Administration. And then in turn, as the program grew, we also made sure that we had to appropriately train people. Again, disinfectants continue to be challenging, and disinfecting wipes continue to be challenging. And I'm sure if you go to the grocery store today, you probably will have a very hard time still finding good, appropriate disinfecting wipes. And so we also came out with guidance and packets on how to make disinfectants that are specific for the reduction of COVID-19 spread, and put out PDFs for this using making sure that it was an appropriate bleach concentration using kitchen cup measuring type modifications so that anyone anywhere could make the appropriate disinfectants with bleach or alcohol solution. And then also moving into the next stage, talking about PPE, we had to provide trainings for people on how to prepare PPE for decontamination. So why do we want to decontaminate PPE? It's kind of gross, actually, if you ask me, but it's still absolutely necessary. Isolation gowns have had an increase in price of over 8-fold. And non-medical surgical masks used to be about 8 cents a mask, and now they're about 51 cents a mask. N95s were completely unavailable, although those are now being recently resupplied to researchers. The reason why they were unavailable was because they were prioritized, reasonably so, for healthcare workers. Vaporized hydrogen peroxide is a way to decontaminate and repurpose PPE. These initial studies were described by Duke University, and Duke shared them with a number of labs through the Regional Biocontainment Laboratory Network. A subsequent emergency use authorization was issued to a number of companies that produce a VHP instrument, and Battelle used it to support PPE decon for primary healthcare facilities. This was a great lift for our healthcare workers. However, if you were not a primary healthcare facility, you still needed support, including many of the CSU groups conducting research, doing surveillance activities, the veterinary diagnostic lab, and also skilled nursing care facilities. So this effort was led by Lon Kendall, who's the attending veterinarian for Colorado State University, and his team, the Laboratory Animal Resources, as well as our lab. And basically, vaporized hydrogen peroxide is a great broad spectrum antimicrobial. It does degrade into water and oxygen, so it doesn't leave a residue or a decay as long as that's appropriately managed. It has fantastic material compatibility, and it does need to be tested with different mixed polymers because it is so reactive. It can be so reactive that it doesn't have contact time enough to appropriately decontaminate something. So you always have to sort of do some in-house testing whenever you're using a new polymer material. And then, of course, if you have something that's densely packed, you're relying on a vapor getting in and intercalating in order for it to have contact time and decontamination. So you do get reduced efficacy if you pack things in too tightly. I'm showing the instrument over here. It's that little blue box, although the tube's coming out of it. And the one thing I want to point out is the green taped door. So you have to use a sealed environment, which means you have to basically tape the door, tape the vents, tape everything that you're going to use for your decontamination room. And then when it's done, you get to untape everything, take everything out, and then you get to tape everything back up again. So little extra fun there. in order to set up VHP, you have multiple different conditioning, pre-gassing cycles, and then you have your contact time, and then you have to aerate to get rid of any residue. So it's about a 4 or 5 hour process. It takes about 24 hours actually for everything to get staged and done. You get a high percent of hydrogen peroxide. Chemical indicators are used to make sure that that appropriate contact time happened. And then this little schematic shows what's going on inside that room. You have this tubing that allows the vaporized hydrogen peroxide to be introduced into the room, and then a fan system. You can't use the HVAC system because that would not that would also be an inlet and an outlet. So you seal your HVAC system, and then you use a room fan basically to circulate for your VHP process. Staging and quality control. PPE are made of multiple materials. A lot of them are waterproof materials, reasonably so for blood, saliva, urine splatter. And so you need to make sure that you have compatibility. Lon and his team tested every single one and then determined whether we could hang them on hangers or whether they could be stacked or hung in these netted bags. We examined everything for torn tags, worn elastic straps, residue, makeup, and etc. And there was a lot of etc. And then also we use a biological indicator, Geobacillus dermathomophilus, which is a spore former. So spore forming bacteria are very hardy. So if you're killing a spore, you're likely killing everything else. That's the logic behind that. And so we would put these spore former cartridges all over the place. And even within, we would tear masks and put them within masks to make sure that we were getting appropriate decontamination. The staging requires training to not only to make sure to do it properly, but also to protect ourselves. We don't know where this material is coming from, who it's been in contact with. Some of it was BSL-3, which is sort of a biosafety level 3, which means high containment pathogens. And then some of it is coming from different healthcare facilities that weren't covered. So that would be what we would consider like a biosafety level 2, where there are pathogens but not high containment pathogens. We don't know that, so we had to make sure that we had the appropriate training, the appropriate gear on when we were staging. And then coming out, we had to make sure that we weren't contaminating the PPE that we were packing up with anything that was incidentally on us. So we also had training and gowning to protect on that other side. And you can see we have stacks and stacks and stacks and stacks of PPE that's clean and going back out into the community. And yes, for you watching at home, that is a peanut butter and jelly sandwich inside of a bag of PPE that we were supposed to stage. So unfortunately, when we received materials like that, we had to destroy everything. So on our final thoughts, we're still conducting studies to evaluate vaporized hydrogen peroxide for additional PPE. A lot of these materials have gone through many, many decontamination cycles. So we're also concerned about tensile strength if it's still waterproof. So we're just initiating those studies, reaching out to our colleagues in the Materials Design Institute at Colorado State University. And then all of our studies included student engagement, both experience and research opportunities for their degrees, which was really enjoyable. And it was very, I think for the students, it was really great for them to be able to contribute and be a part of something during such a time of uncertainty. With that, I have a number of acknowledgments. I especially want to thank Jackson Watkins and Ann Simpson for their leadership with the hand sanitizer and disinfecting wipe effort. And then Anne, Madison and Niall Stoltz and Madison Russell for assisting with the PPE. Lon Kendall and all the LAR staff for the PPE, especially Cheryl Carter, who sets up all the VHP for us. She does all the monitoring and setting everything up and running the instrument, as well as support from a bunch of letters, Vice President for Research, Vice President of Operations, OC Health, Biosafety, College of Veterinary Medicine and Biomedical Sciences, Environmental Health Services, the Pandemic Preparedness Team, Purchasing, Central Receiving, and my home department, away from home, microbiology, immunology, and pathology. And finally, our community partners, Gilded Goat, Copper Muse, and now also Old Elk Distillery. Thank you. Turn it over to Brian.
Yeah, go ahead, Brian. You're also on mute.
Okay.
There you go.
And I will. Great, and thank you for joining us tonight. I want to talk about how the CSU Energy Institute really pivoted and relied on our core values of innovation to assist in the COVID-19. And I think this is really interesting because it's, we aren't innately involved at the health field, but we do have a core set of skills around innovation that we sought to repurpose to assist in the COVID fight. So the CSU Energy Institute comprises over 250 faculty members at CSU across all 8 colleges and dozens of different departments. And of those faculty, about 30 of them are resident at our Powerhouse Energy campus, which is about 1 mile north of the main campus. And the mission that the Energy Institute is to accelerate the development and adoption of clean energy and climate solutions on a global scale. We seek to do this by harnessing resources at CSU, and we work to accomplish this mission by accelerating energy and climate solutions research, developing and disseminating technology solutions, promoting education, and supporting the development of informed policy. We've expanded beyond just energy to look at both energy and climate solutions. And our core, set of values is to understand how we can develop and implement solutions at scale. So I want to talk a little bit about, before we get into the specifics here, what all this means. A core belief I have is that universities can drive disruptive and transformational innovation at large scale, but that's a very different way of operating than we normally use at universities. So our mantra is really what we call science solution to scale. So looking at what the fundamental science barriers would be around a particular problem, and a lot in the university world, we sort of stop there and we do a piece of science, we write it up in a paper that goes in a journal, we go on to the next interesting problem. What we've sought to do is to basically take that science, turn it into solutions, and then work with partners to get solutions implemented at scale. And this, if you really think about the way universities work, we often are very good at a particular thing. And then we seek to write papers or apply that thing in different fields. Innovation is very different. It works from identifying needs and then building responsive teams to do this at scale. One of my favorite theorists on innovation is Andy Hargadon at UC Davis. And he talks about that innovation isn't about the idea from one person. It's not the single lone inventor. It's the large network you put together to get things done. So I kind of want to talk about that in the context of COVID solutions. So our work with the Energy Institute really began in mid-March, identifying the needs for disinfection, for PPE, and ultimately we received a governor's office essentially asking the universities to pull out the stops and seek to use their networks to address several key issues. And 2 that we really focused on were the need for PPE, and particularly N95 respirators, and for ventilators. So many different activities here at Powerhouse. And I'm going to talk more about the ventilator design. But one of the issues we faced early on was that Colorado was seeking to source N95 masks. Conventional trusted sources were tapped out. We had, the state had contracts in place to buy from unverified sources in China and elsewhere. And they really needed to know if you could people's lives to these new masks. So it turns out we actually have a great group that works on aerosol sciences, and the principals in that are John Volkins and Christian Larange. And we actually had the equipment in place to do N95 testing. So what this involves is actually, it's a whole subject in and of itself, but essentially spray salt solutions, and then as the water vaporizes, you're left with salt particles of a very precise size, and those are then pushed through a mask, and you look to see what those particles get through the mask. So they have, CSU is the designated quality control facility for N95 masks in Colorado. So essentially all the samples from that the state has purchased are sent up to CSU and tested here at Powerhouse in the lab. A couple of really cool things that have come from that is that there's been a lot of work by engineering faculty and understanding now what it means to have aerosol transmission of the virus. The National Academy of Sciences put on a workshop about 6 weeks ago on the aerosol transmission of the virus. John Volkins from CSU organized a half-day workshop on engineering aspects of aerosol transfer. And there were 14,000 attendees who watched that workshop online. Some of the work we're doing now also supports, and actually I've got to talk about the other one at the lower left. We actually have an exposure chamber at CSU that was originally built to do human subjects exposure testing for cook stoves. And basically these were the subjects would go into this chamber, and we would pump in very precise amounts of smoke, and they would look at immediate physiological response of the test subjects. It's all safe from safe levels, and there was obviously very rigorous institutional review on the protocols for that. But that facility was, we were contacted by the music community who was seeking to understand the risks that would come about from musicians, and particularly singers and wind instrument players who would potentially be pushing aerosols into a room. And this is the real question, is how risky of an activity is it for school students to be singers, to learn to play an instrument. But this work was supported by everything from individual PTAs and moms and dads to symphony orchestras to music associations. In the lower left is actually a singer from the Metropolitan Opera who heard about the study and came down to sing and be tested. So, you know, something very different than normally happens at Powerhouse. A couple things going on right now. So, there was a great piece on NPR just a couple days ago on colleges doing effluent testing. And they focused really on efforts at both CSU and Colorado College. And these are some pictures from that. If you haven't seen this, I urge you to go to just Google NPR and effluent testing, you'll find this. But one of the challenges is sampling the sewers is actually challenging. And that's because the sampling systems we used were not designed for this purpose. They take fairly large samples. They gather about 8 liters, so 8,000 milliliters of sample, and that's what the samplers are meant to do. We need to do genetic testing. We need about 50 milliliters, which is about the size of an airline liquor bottle. So we're basically, the equipment it's in current use is very large. So one of the things that I've been asked to do for that is to assist some things like developing a better sampling probe. And so on the right is actually just a prototype that came off the machine out of the prototype lab today and is going over for testing in the next sampling round. But I want to move on now to talk about a specific project and focusing on ventilators. And I'm going to let this video speak for itself. And it occurs to me that I may need to make sure I have the video turned on. Corey, can you tell me as well? I'm going to start playing this and tell me if you can hear the sound.
Yep, I heard it.
Okay, great. And we'll continue.
The Aether 100 emergency ventilator is a rugged, portable ventilator that leverages Woodward's capabilities in designing safety critical systems for the aerospace industry and the energy and power industries. To develop the Aether 100, Woodward and CSU collaborated on a process we call disciplined urgency. The idea here is twofold. First, we have to be very fast in order to provide a ventilator that provides for the humanitarian needs we see in the COVID crisis right now. We also wanted to ensure that we stay disciplined to our processes and that everything we did was safe to breathe for a patient.
Our approach was really to build on the 30-year history between Woodward and CSU working jointly to develop solutions for global energy challenges. At its most basic level, a ventilator needs to precisely shape the flow of air into and out of the lungs. Much of our work with Woodward over the years has involved shaping the flow of air and fuel into large industrial engines, such as the one that I'm sitting on here. So what we did was go into Woodward's portfolio of industrial control products to stitch together the components to build a ventilator that was able to use Woodward's supply chain on medical supply chains.
We have developed this product in a very short time. That means team members from Woodward and CSU in Colorado has put in long hours. And it's a global effort. We have teams from Europe and India also participating in this. In all, we had 24 hours a day work going on.
So our ventilator uses high-speed digital valve technology that we developed for metering natural gas on natural gas engines. These injectors are used on large 18-wheeler trucks. They live under the hood in very high temperature and high vibration environments and last years. For the exhale PEEP valve, we're using a precision rotary actuator that we developed for controlling air and fuel flow into natural gas engines as well. This component also is very ruggedized for use on engines, and it pinches a silicone tube in order to precisely control the exhale process. All these components are very durable. They're meant to live in high temperatures and high vibration environments. They're packaged inside of a very ruggedized case so that the whole unit can go into a truck. It can be stacked up to the ceiling, can go on rough roads into very remote regions all over the world.
The brains of the Aether 100 are a ruggedized engine controller that was developed by Woodward for industrial applications. Woodward has a sophisticated set of software tools we've developed to control airflow into engines, gas turbines, and even aircraft engines. We can develop control strategies using these powerful tools, then download the executable code to the Aether controller. The human-machine interface is a ruggedized product that Woodward developed to control electronic generators, but has the functionality we need for setting the patient parameters and providing feedback to the medical team.
Woodward's forte is in developing complex engineered systems. At the heart of a complex engineered system is systems engineering, where we try to define and refine requirements and specifications. While the design team investigated hardware options in different configurations, systems engineering team was looking to refine the parameters needed, such as respiration rate, tidal volume, peak inspiration pressure, positive and expiratory pressure, and fraction of the oxygen. After consulting with pulmonologists, respiratory therapists, medical school professors, bioengineering professors, respiratory technicians, the current operating modes that we decided on were volume control with pressure limits, pressure control with volume limits, and pressure support. We needed to be able to control breathing for a patient when they are incapacitated, and yet be able to assist them to breathe when they are recovering, when they are able to take a patient-triggered breath.
The Aether product has the ability to be the most durable, full-featured ventilator. To ensure that it lives up to this potential, we've done extensive supportive analysis and accelerated durability testing. The inhalation valves were originally designed for use with natural gas, so to ensure their compatibility on oxygen, we performed accelerated durability testing here at CSU's Powerhouse Energy Campus and shaker table testing at Woodward's Lincoln campus. We used computational fluid dynamics to support the design process and to ensure undue wear on any components.
Although Woodward has factories across the world, we don't develop any medical products currently. So when we took on the ventilator project, we had to leverage off of our abilities, which is designing safety critical control systems for aerospace and energy markets. The Woodward facilities we plan on building the Aether 100 are all AS9100 certified. This is an aerospace standard that allows conform products to control what goes into them and to test them to ensure they're safe and reliable when they go to the customer.
We have consulted with a team of pulmonologists, respiratory therapists to get the clinical background for the product. And then we've done testing with colleagues at the University of Colorado Anschutz Medical Campus to actually test the system. We've applied for emergency use authorization from the U.S. Food and Drug Administration and are now engaged with them on that review process. We submitted our system to the U.S. Army's COVID ventilator challenge, and out of the 200 entries, we were one of the 5 that were selected as winners. We received $100,000 from that competition and are now engaged with me on negotiation for a development and demonstration contract.
We are currently exploring applications of the ventilator in developing nations and for the Department of Defense. The Department of Defense is interested in having an insurance policy for a potential second wave of the virus, and in many of the developing world countries, they simply don't have the medical infrastructure we have in the US. I wanted to take a moment to thank CSU and all the different people across Woodward that helped out with this project, from people in Germany, Poland, India, and all across the US. We had many, many people come forward and work on this. We had a lot of long, hard hours. We worked weekends. And what I have to say is across the board, the teammates, whether they're at CSU or Woodward or at our supply base, everyone just pitched in with the common goal of doing something for humanity. And it was really heartwarming for me personally.
So the epilogue to this is that ultimately the demand for ventilators, the crisis in ventilators declined. Supply base came online, and new treatment technologies did not rely as heavily on ventilators, but it was really just a great team example of teamwork to bring 2 unconventional teams together who'd never worked in this field, quickly dive into understanding how to design, build ventilators, get it through the quality assurance process and be there ready in case the need came. So that really concludes my remarks today, and I think we are now would welcome discussion or any questions from the audience. So thank you very much, and I'm going to turn it over to you, Corey.
Awesome. So while we are sitting here, feel free to type in any more questions for the Q&A area or in the chat. First question, I believe, is probably for Karen. What is the stability of H2O2 in your hand sanitizers?
I saw that question. That's a good question. Hydrogen peroxide is very stable until it's exposed to air. So as you can imagine, and then especially if it's in an aqueous versus an alcohol environment. So it's relatively stable in a hand sanitizer, but the more you open and close that bottle, the more you're getting a reduction in hydrogen peroxide, just converting it to water and oxygen, and you'll get, it becomes relatively ineffective quite quickly. So that's why even if you buy like the Megalo hand sanitizer bottle, it's a smart practice to just go ahead and have a bunch of small sort of pocket or coat or purse sized bottles that you use, and because that'll allow it to last a lot longer, quite honestly.
Awesome. And really, that's all the questions that we had, which usually I tell people, hey, if you have no questions, then you did your presentation correct. Oh, wait, as I said that, we get another one. I have read about the COVID cases on campus are more than 500. Would either of you guys be able to say more about that or talk a little bit about it?
I'm deferring to you, Karen, as probably being closer to the daily case count. So I will say there are daily meetings on COVID, reviewing the results from the nasal testing and from the effluent testing. This is something that actually just really makes me proud of being a RAM, being at CSU, how active and aggressive CSU has been in monitoring this. And in a lot of cases, there really aren't solutions for testing and getting the information we need. And CSU has just been willing has really been encouraging the research community to figure out how we fill in those gaps. So it's just really been heartening to see how actively and aggressively this is being addressed on campus.
Yeah, I agree with you, Brian. It has been every member of the CSU campus has been engaged in helping with either norming or direct support, contain and assist with reducing the spread of the disease. Of course, we're heading into colder months, which tends to pose challenges, of course, with more temptation to kind of gather inside and we can only hope that we continue to show our progressive RAM stalwart attitude towards helping to just manage cases, manage our quarantine dorms, and continue to make it through the end of the semester, and then hopefully into the spring semester next year.
Awesome. Next one would be, could a home test be used, kind of like a pregnancy test for testing?
I don't know what we can say, but I can just say that there is, I can't, not for fecal testing, but there is work being done on rapid response testing at CSU. I don't know, Karen, if you know more what can be said, but it's another area that just really makes me proud of how much innovation is going into that.
Yeah, I agree. Both rapid response testing and then using saliva as an alternate testing modality, so that you're not having to rely on the nasal pharyngeal swab and making sure that that's appropriately sampled. So everything that Brian just said.
Given the choice between a home saliva test and a home fecal test, I'm going with saliva.
Cool. I got a couple more that we have from before when the event started. Number one is, are there certain disinfectants to use in the kitchen area where food is being prepared?
That's a good one. So, you know, your two options are bleach and alcohol. You know, bleach is a better disinfectant that is going to inactivate everything, and you know, including SARS-CoV-2 and other more resilient organisms. It does, of course, have a you know, a significant issue with the kitchen. There's a lot of kitchen cleaners that use bleach, actually. So so you know, in a pinch, actually, you know, that's going to be your most conservative one. But then you also have environmental issues with contamination and drainage of high bleach solutions. You don't need a lot of bleach. So I would say if you're going to go with a home cleaner and you're going to go with bleach, make sure that you're diluting it appropriately so that you're not increasing environmental contamination. Otherwise, alcohol does work very well. Ammonia works well, but the jury's still out on whether or not ammonia is effective against SARS-CoV-2. So unfortunately, we can't rely on that, or life will use vinegar is another one that people like to use that is more environmentally friendly, but we just don't know. We just don't have the data on how effective that is against this virus.
I think the one thing I would say is we don't want to let the enemy or the good be the perfect be the enemy of the good. Given the choice, cleaning the counter, I mean, you know, with our hands, we know that soap and water is effective if given enough residence time. So almost any cleaner has some effectiveness in reducing the number of virons on a surface. But I also would say that the recent, you know, there's much less evidence of significant fomite transfer, you know, from surfaces as there is from aerosol and droplet transmission.
Cool. Next question was, will UV light be an effective disinfectant?
So that's another one where you have to be careful. So there's two different bands of UVC light that are effective. The most common is also damaging to the eyes. So you've got to, you know, if it's in your little canister to sterilize your phone, fine. But they are used in hospitals, but they're targeted only for areas in the upper zones of rooms, and common in design of tuberculosis facilities. There is new work on a safer band, and I think 222 nanometers, but that still hasn't been fully proven out. So UVC is certainly interesting. It's one getting a lot of attention. There's work going on here, but it's not one I would recommend for the home. You know, for do it yourself at home because of the danger of UVC radiation.
Cool. And then this one. Do either of you guys have any information about the sewage testing going on at CSU? If not, I actually have that as maybe a possible conversation that we have in a further COVID series.
So I will send you to that NPR article just from this a couple days ago. That was you know, great article. Talks about the effluent testing, and that's one kind of doing engineering support to that team, and just some great science going on. Not only taking the samples, but actually is on the call today. And Sunday during the big snowstorm, the teams were out from 6 in the morning till 5 in the evening, sampling sewers in that storm. So those are, those students, they're heroes for that work. And the work that's going on to not only do the science of the PCR, the genetic testing, but then we also then, as we start to get the data, no one quite knows what to do with the data. And so there's a data analytics team that are getting into this to look at how we look at the data and start to assign causality to things. So that's it. That's one that's really cool because it does involve the testing, but all the way through to the data science and analytics.
Awesome. Besides that, I don't have any more questions unless anything comes in the next couple of minutes. So everybody, again, thank you so much for making it today. We will be posting this on YouTube in the next upcoming weeks or so. So if you ever need to come back to it, feel free to look up our YouTube channel on the CSU Alumni Association page. I will also post the links that I posted in the very beginning of the presentation here. And thank you again, everybody, for making it. And go Rams.
Thanks all.
Thank you, everyone.
Thank you.